Good day everyone, welcome to our first video, our first activity that we're going to do today. Our activity is a laboratory activity 4.1. So, this is a machine problem, so a programming problem is sentence statistics. So, we must write a C program that reads maximum 200 characters including spaces and produces 6 statistics about the line use string function such as string string copy, string compare, and string joins where they simplify the work, and manual character by character scanning were appropriate. So first task, so we have few tasks here. So first task is we must print the total number of visible characters in the line. So we must not count the null terminator. And second is count how many words the line contains. A word is any consecutive sequence of English letters. It could be uppercase or lowercase. And third is count how many vowels such as a, e, o. It should be case insensitive and how many consonants appear inside those words. So and then ignore everything else. So we must print if the line first word and last word are identical. It should be case insensitive. Otherwise, remove all non-letters characters, convert the rest to the same case, and report if the resulting strings read the same forward and backward. And otherwise, output the entire original line in reverse order. It should be character, not words. So let's proceed to our code here. So first we have our file type. So we have two file types. So first is standard input output responsible for the scanf, printf, and etc. So sharp includes string, which is responsible for the string copies, string length, string joins, and etc. So that's all the file type that we include in our program. So second, so we have our function declaration here. So we have void here, which is the vowel and consonants. So this function is responsible for counting the words, vowels, and consonants in the string or line. And then second, we have our void also, which is the first and last word. So void is does not return value. So first and last word. So we're going to compare the first and last word of a string. So first we must extract the first and last word and then compare it. And then thirdly, we have our car, which is responsible for reversing the string or line. So we reverse it. And fourth, so fourth is car clean string. So this function to clean a string, so to remove a non-letter characters and convert to lowercase. So this purpose is very helpful for the is palindrome. So this function is responsible for to compare or check if a string is palindrome. So so if the line is read the same in backward and forward, then it is palindrome. So this is all our function declarations in our code. So this is our main function. So this is our int main. So as you can see, we have three variables that we declared. So first is the original string. So this is where we store the user's input. And then we have our int for counting the number of vowels, number of consonant, and number of words. And then lastly, we have our clean string. So first is we display a guide for users to input how many characters should be entered. So we have limited for 200 characters. And then we use fgets to store the user's input in the original string as I declared it above it. So if you're notice, so we have a kind of line here. So this is responsible to not include the enter. So what it means that when users input a string and they click enter to confirm that to confirm the user's input. But when enter and when we use string length, the enter is included. So there's additional character that included in the string length of in the original string. So we must include this to not include that, and also the null terminator. So first, our first task is print the total number of visible characters in the line. So we must not count uh, the null terminator. So we have here. So we use so first of all, there's a preview of our user's input. So this is this is the preview to show the what what the user's input is. And then we have our printer for number of characters to display the string length of original string. So string length is responsible to count the number of characters which not included the null terminator. So we have our placeholder, and then so next we have our another variable declaration. So this is a paragraph for counts. So this is responsible to count the word, vowel, and consonant. So we make a copy for the original string. The original string is responsible to store the user's input. So it is a line of character. So we use it for the function of vowels and consonant. So this is a function call. So we call a function to process our in of the user's input to count the number of words, vowels, and consonants. So this is how we display it. So let's go up here. So this is our function for vowels and consonants. So this function is a void. So it indicates that the function does not return any value. So instead it modifies the integer variables passed to it. So this is the name of the vowels and consonant, and then we have our pointer for the to pointer to a character array. So we have int vowels also, and then integer consonant and integer for words. So this is where we store the count of vowels, words, and consonants. So first we have our initialization here. So so we put all of we put value of 0 each of these integers. So this line differences the vowels pointer and sets the integer variable it. So it points to 0. The initialize the vowel count to 0 before processing the string. So same as go with this. So we have here um, a loop. So we loop each character to determine if it's a vowel, consonant, or is it part of the words. So we have initialization of here of I, which is equal to 0, and then string is I is 0, and then is not equal to null terminator and increment the I. So first we have here the if. So this is about responsible to checking for alphabetic characters. So if the first character is or the zero index of character, which is the example we enter Lawrence, which is my name. So L. So is it a capital? Is it a uppercase of A? Is range to Z? Capital I uppercase A to Z, or it could be lowercase. Then else is if else, so n is equals to 0. So if the character is not alphabetical character, example space, punctuation, or digit, it means the current sequence of letters, if any, has ended. So the end flag is a set back to 0. So first is we must count. So we count the number of words. So this is our if to count if it's word. So this condition check if we are currently not inside a word. This is true when we counter the first letter of a new word after a non-alphabetical character or at the beginning of the paragraph. So this line is if we not in a word, it means we're encounter the start of a new word. So we increment the value pointed to by the word's pointer, which is to effectively increasing the word count. Then this n word is then we set the inward flag to 1, indicating that we are now inside a word. So and then for our next line, so we have here to convert the string to lowercase. So the purpose of this, if the user input is capital, we must we must convert to lowercase so that we can determine if it's vowel or consonant, because when the user's input is in uppercase, we're not able to determine it if it's vowel or consonant, because uppercase and lowercase is different. So we must convert all the user's input to lowercase. So so this is the manual lowercase conversion. And if the character is equal to A or E or I and O and U, which is the vowels, then the vowels will increment. So as you can see below it. And if else, if it's not able to detect it is a vowel, then it is a consonant. So it will increment the consonant variable. So so this function is iterates through a given string, character by character. So it identifies letters, convert them to lowercase, and then checks if they're vowels or consonants. Incrementing the respective counters, it also keeps track of whether it's currently inside a word to count the number of words in the string. So this is how we make how do I develop a program to count the number of words, vowels, and consonants. So our next function is comparing the first and last word. So this is the function code. So let's proceed with the function. So here is so So this function will take a string as input and determine if its last word and first word are the same, ignoring case. So first we have our initialization here. So we have character temp paragraph for words. So character paragraph for words. Um, so this is a temporary character array to. So this is responsible to this this is used to for this string copy so that we copy the original string to this variable. So in extracting the first word, so we declare this variable just a character. So the if you wonder, this string token, we use this to tokenize the theme paragraph words or string. Delimiter used here is a space. So as you can see, the first call to string token with the string itself returns a pointer to the first word found before the first space. This pointer is stored in first word and then finding the last word. So initially the last word pointer is set to the same value as first word. This assumes that if there is only one word, then it's both the first and last. And then character token is a pointer token is declared to hold subsequent words found by string token. So while so this loop continues as long the first or the pointer first word is not null, meaning there was at least one word in the string. Subsequently call to struct string token strtook null space returns a non-null pointer. Importantly, when string token is called with null as the first argument, so it continues tokenizing the same string from where it left off in the previous call. Each successful call to string token returns a pointer to the next word. So, so inside the loop, last word equals token. Each iteration, the last word pointer is updated to the point to the newly found token. This ensures that after the loop finishes, last word will point to the very last word in the string. So here is the comparing the first and last word if both exist. So so comparing first and last word if both exist. If 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 this condition checks if this if condition, so this conditional statement is or this condition checks if both first and last word are not null. So meaning the input string contain at least one word and potentially more. So we have here a lowercase conversion manually for comparison. So in this, so we have our, as you can see, we have our declaration here, a character. So two character arrays, lower first and lower last, are declared to store the lowercase version of the first and last word. So we use string copy here. So lower first copy the first word and lower last copy last word. So these are loop. Inside the loops, they check if a character is an uppercase letter between A and Z. If it is, 32 is added to its American Standard, which is the ASCII value. to convert it to the corresponding lowercase letter. So this used to case and sensitive comparison. So this is the two loops that going to convert it into lowercase. So let's proceed here in the if condition statement. So we use a string compare to compare the lower first and lower last if they are identical. So if it equals to 0, then the first and last word are identical, so it's yes. So if else, then it is no. So this is this else if is responsible to handling the single word input. So in this case, the first word is also the last word. So it will print first and last word identical. Yes, only one word. So because users input as is unpredictable. So here our else is if the user inputs it empty, then it means the input string was empty or contained only spaces, and string token didn't find any words. In this case, the message indicating that the first and last word are not identical due to an empty line is printed. So overall, this function is use function use string talk to find the first and last space separated words in a string. So it converts them to lowercase and then compares them to determine if they are the same. Is the so it also handles the edge cases of a string with only one word or an empty string. So now let's proceed to our next function. So this is the palindrome check. So this so in the instruction, so first we must clean the string because we must remove the non-letter such as spaces, pointers, digits, or etc. So let's proceed to our function. So where is our function? So here. So this clean string function takes an input string str and produces a clean version containing only lowercase alphabetic alphabet alphabetic characters. It stores this clean string in the clean character array, which must have a size specified by clean size. So first we have our initialization here. So this nj is equals to 0. So this index will keep track of the current position where the next clean character should be placed in the clean array, iterating through the input string. So let's proceed to our for loop. So this our loop. So iterates through each character of the input strings str until the null terminator is encountered. So signifying the end of the string. This is the character filtering. So some this variable declaration is a character. In each iteration, the current character from str is assigned to the variable c. So so this this if condition checks if the current character c is an uppercase letter or between a 2z or lowercase letter, converting to lowercase. So yeah, this will convert it to lowercase. Then if c is greater than or equal to a, So if it's character in uppercase, this inner condition converts it to lowercase equivalently. This is done by calculating the offset from A and adding it to an A. For example, if C is B, if if C is B, then B B is minus A is 1 and A plus 1 result in B. So adding to the clean string. So this line is, so if the character C, which is now guaranteed to be a lowercase letter, pass the filtering, it is added to the clean character array at the index J. So J will increment. So it will increment to the point to the next available position in the clean array and then null termination. So this is at null termination. Then return clean. So after the loop finishes processes all characters in the input string, null terminator is added to the end of the clean array at index. This is crucial because it marks the end of the clean string, making it a valid C style string. So return the clean string. So this is our clean string. So our next function is our palindrome. Determine if we reverse or if we backward or reverse the string, it will read the same, such as Madam. If we reverse it, it is the same. It is also Madam in reverse. So it is palindrome. So we determine it if the user's input is palindrome. So let's proceed here. So we have here our palindrome. So this function checks if the given string or str is palindrome. Reads the same forward and backward. So first we make a copy of the str. So as you can see, we declared a variable here, a character variable. So it is a string. It is a reverse variable name reverse variable. So we use string copy to copy the str to reverse, and then we declare a function call here, which is the string reverse. So before we palindrome it, I check if the string is palindrome, we must reverse the copy string first. So we have here st the string reverse. So this function takes a string as input and reverse it in place. So first we have our initialization here. So determines the length of the string and set two pointers, which is L to the beginning and R to the end of the string. So this is where reverse the loops. So iterates as long as the left pointer L is less than the right pointer. So it collides. If the L and R is collide, then it will stop. So it temporarily stores the character at the left pointer in T. It swaps the characters at the left and right pointers. It moves the left pointer one position to the right, which is will increment. And it moves the right pointer one position to the left, which decrement, the R. So, tagbo na sila or collide. Then it will return value is A. So it returns a pointer to the modified reverse original string. So let's go back to the palindrome function. So as we make, so we did make a copy of the original string, then we function call. So here we determine or compare the original and reverse string. So if str and reverse variable is equal to 0, then we display that 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 the string reads the same forward and backward is yes, and else the string reads the same forward and backward is just no. So this function is responsible to compare ay, to compare the original and reverse string if it's identical. So our next function is reversing the string. So it is the same of the or the string reverse function. So um, we just copy it here to make a to display the reverse string. So we make a variable here, declare, and then copy the original string to reverse. Then we make a function call to reverse the original string, which is stored now in the reverse, and then we display the reverse string and placeholder of string, and then we just assign to reverse. So it will return to 0. So this is the end of our program. So now I will present to you the output. So let's run this code. So first let's input I am Jennifer Lawrence. So so just like what I explained, so first we have a preview, then the number of characters, so 22. So let's count it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So it's correct. So it has 22 characters. So total number of words. So we have 1, 2, 3, 4. So we have 4 words, and we have 8 vowels. So is it? So 1, 2, 3, 4, 5, 6, 7, 8. So it's exactly 8. So it's correct. So how about consonants, which is we have M. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 is correct. So is it the first and last word are identical? Yes, I and then Lawrence. So it's no. So this is the clean string. So I am Jennifer Lawrence. So I am Jennifer Lawrence read the same forward and backward. So no. And the first string. So I am Jennifer Lawrence. So it's reverse. So that's my output. So thank you for watching. So this is my laboratory activity 4.1. Thank you.